Swayam Prabha. Digital India. Educated India.
We will now show an example illustrating this superposition. So, let me take a circuit similar to what I had in the illustration. Okay. So, I have three current sources. V1, I2, and let me just reverse the direction of this, I3. Okay, and let me call these R1 and R2. And let me say that what I am interested in is the current Ix. So, the problem is to find Ix in this circuit. So, what do I do? Following my method of superposition, I take the exact same circuit, but first, in the first step, I have only V1 and set I2 to 0 and I3 to 0. So, what does that mean? These two have become open circuits. Okay. Now, the resulting circuit is a single loop circuit with V1 applied across the series combination of R1 and R2. Okay. So, we can find the current in this loop very easily, and you know that is V1 divided by R1 plus R2. And if you look at the definition of Ix, it is in the same direction as this current. So, Ix from the first step will be V1 by R1 plus R2. Okay. Now, in the second step, I set V1 to 0 and I3 to 0, which means that this becomes an open circuit, and V1 being 0 makes it a short circuit. Okay. Now, again this is drawn in a strange way. If I redraw it, all I have is I2 applied across R1 and R2. Okay. And Ix is the current. This is what I meant by being careful. You please mark the nodes. Ix is the current flowing downwards from here to there, and that is what I have taken it to be here. Okay. If you are getting confused with this in a larger circuit, you number all the nodes, keep track of connections between nodes. Okay. So, in this case, what do we have? Ix will be equal to I2 times R1 by R1 plus R2 from the current divider expression. So, in the second step, this is what I have got. Okay. And finally, the last step, I set V1 to 0 and I2 to 0. So, that means that this becomes a short circuit, and I2 being 0 makes it an open circuit, and I have only I3. And just for convenience, I will redraw that once more. So, again it is I3 applied across R1 and R2, and Ix is defined in this direction. Okay. So, now the current flowing through R2, so this total current I3 gets divided into two parts and flows into R2 and R1. The part that flows into R2, this part is given by I3 times R1 by R1 plus R2 from the current divider expression. We also see that this current that we calculated is in opposite direction to Ix. So, Ix is minus I3 times R1 by R1 plus R2. Okay. So, we have the results from the 3 steps which we sum together to find the current Ix, the total current Ix, and that is given by Ix is V1 divided by R1 plus R2 plus I2 times R1 by R1 plus R2 minus I3 times R1 by R1 plus R2. Okay. So, this is how you use superposition to analyze circuits with multiple independent sources. Okay. So, these are the circuit analysis techniques that we can use, but these are kind of ad hoc. Okay. By looking at the circuit, we make parallel and series combinations and from there find the solution. So, the superposition is a way of extending this analysis with single independent source to multiple independent sources. In the next couple of units, we will be looking at systematic methods of analysis for arbitrarily large circuits. Okay.